Okay, so we will continue Unit 3 today. And the lab, we're going to talk about how to do malware analysis, but using Wireshark, which is the network monitoring tool. And the lecture today really focused on data or evidence acquisition. So I think these two, the plates are missing on it.
Oh.
The top.
Oh, yeah. Okay.
It broke off or something like that when they push it down. So I will have them look at it tomorrow. There might be a latch that goes underneath it somehow. Okay, so we're going to talk about how to be able to acquire evidence and then going through the process and looking at the procedures. So it's going to get in depth. I think we talked about procedures prior to our little break a couple weeks ago, right? So in the first part, it talks about evidence, right? So evidence is really facts that you're obtaining, and sometimes they call that as artifacts. So that could be your data, right? It could be an email. It could be network traffic information. And today we're going to look at that and malware. So what you want is you want to find the fact, and so that way it would be correlated to what your case might be. And it tells you here that do not forego the proper evidence handling procedure, and that's really important. I think we really emphasize on how this can impact in a legal manner, right? And making sure that you have procedure, methodologies, and processes. And we talked about how we would use the tested tools and making sure we have chain of custody. So let's go through some of the questions so you can understand. For number one, it says, how should you handle evidence? First, we want to make sure that there's chain of custody, meaning that we want to record, right? All of the information about the system that we're working with to gather evidence, the time that we access it or acquire it, I should say, and who, right? So we want to make sure that there's timestamp and information on the form, where it's stored and how it's stored. And we talked about how we would take an image of a system and examine the image, not open up the files within the system itself, right? So making sure we have chain of custody, that's just proper record of your system that you're gathering evidence from, and making sure that you secure it properly. So even with storage, right, if you're looking at disk, making sure that it is in anti-static bags, right? We want to make sure we tag it. And when you put down information on chain of custody form, making sure we put proper model number, right? And specific details about that particular component or system. That's important to think about. Now, how can you make sure that your procedure is validated or your process is validated? I think we mentioned in the last chapter that we want to be able to scientifically show that there's validation through the repetition of procedures. So if you can repeat the same set of steps and produce the same result, right? Or a very small margin of difference, because sometimes, and then we have to explain why it's different. But if you're able to repeat the same steps and have the same outcome multiple times, then your procedures are validated. So that means that sometime when you gather the evidence, you use a tool to scan, right? And you have to repeat that same step. So that way you want to make sure that the first time the result from the first scan is equivalent to the second scan. And then if you're using multiple tools to compare, you have to do the same thing. So this is why this particular area of the field takes time, right? And resources. So we want to repeat the procedures and making sure we get the same result. Now, number 3, it says you should have forensic sound examination environment. And what does it really mean, right? Describe that. And why is it important in the investigation? So your methodology when you perform the evidence acquisition, it needs to be 1, thorough. Okay. And this is going to take the effort, like as in time, the resource, the amount of work that you will put into it. And you have to be methodical and you have to apply critical thinking in the process. So you have to perform methodical and thorough the digital investigation. So the forensic, now, as we look at a lot of data and our data sets can be large to be able to obtain evidence, you're gonna see that you kind of have to really dive a little bit deeper when you're looking through your data. For example, we have to look at the tags for the images. Even if you have thousands and thousands of files, we have to be able to do that. And if you are more thorough, that's gonna reduce the number of error, right, or the mistakes that you have in the investigation. So it's recommended that we are detail oriented when we do this, right, and we're methodical when we do this. Okay, so you can find some of the suggestion that you see. It talks about validation of procedures here, right, and the requirement. And so you need to have control of your working environment based on the notes, and it tells you that in for forensic examination. And also you want to have a certain expectation of your outcome. That will be your goal toward that particular case, and that you can build the process for it. Okay, so if you have a plan, right, and you have a certain expectation of your investigation, then you can set your goal, and that's how you can plan out your timeline on the procedures and how you would investigate. And then forensically sound examination environment. This is going to be the next section here on page 1. Okay, so as you know, in all areas of cybersecurity, digital forensic is also very quickly evolved, right? You have new systems, you have new media, you have new storage, new technology, and then new tools. So it's recommended that you continue to train, so obtain skill sets, so that way you can apply, right, all the knowledge and the skill sets that you learn throughout your career toward your practice. And I recommend for all areas of cybersecurity. So when you snooze, you lose, right? You have to keep up with the industry, because the tools that you have been using last year will likely be older tools, or the version have changed quickly. And this is harder with cybersecurity, is because it's quickly developed and then it's quickly changing because of the demand in technology. So you need to be aware of the changes in your tool that you use and the practices of the field. And then so that way you can continue your knowledge and skills preparation. So if you obtain certification, they require that you have your CRUs, right? Your learning credits, so that way you can maintain your certification. If you don't have certification, I would recommend exploring like the various area of your tools, the tool sets that you have, and scaling out your tools so that way you are more prepared. But in order to become a forensic examiner, most likely that you're gonna have to have a certification in this area. So if you want to pursue this, right? But if you're only learning this because you want to be a cybersecurity analyst or a crime analyst, right? You still need to keep up with the tools, because you will likely need to use some more current tool. And AI incorporated tools is what we see quite a bit now for analysis, especially with larger data sets. Okay, so it talks about this with tool validation. I think we touched on that in the last unit. You would be able to have a link, right? NIST offer a way that you can use a validated tool that's on the list, or you can submit your tool to be able to validate. Now it says that you need to know where the artifact found by the tool is located in the file system or the operating system. So when you have it examined, right? Like the software you use, it's gonna tell you that it's gonna place the file or the specific artifact in a certain area. But you can also customize your folder, right? The more organized you are, the easier your life's gonna be in security. So we want to make sure that you know where your files is gonna be placed, because sometimes you have to have protection for that location so that way no one can access it, because if it is for a court case, right, you don't want contamination of evidence. So we have to encrypt it, we have to password protect it, and we have to make sure that the permission is restricted, right, for other people to access. Okay. And it tells you here that if your forensic tool is found faulty, right, the tool can be discredited, especially by the attorneys, in the case that if it goes to court. So the 4 important elements that you need to understand: make sure that you know what your tool does, right? A lot of times when we do the lab, some students just click the tool, scan, and then they might not even, they took a screenshot, but not even looking at it. So I challenge you to kind of look at your outcome and try to understand what that means, right? If you don't understand it, you should explore and learn what it's giving you. So first thing, we need to know what the tool is doing, right? What it's giving you, right? And then you have to ask yourself, is this tool accurate? So that means that we can test it multiple times to see if it's giving us the same output. You also need to make sure that you have backup information to show that you are knowledgeable in this area. So you need to document your training, right? And then you would need to make sure that you have the knowledge concept. So notes during the exam, validate the tools. So this is examination, right? So as you go through the data acquisition or evidence acquisition, you need to make notes. So this is a challenge with students that did the project in the past year or so that I see, right? They take a bunch of screenshots and then they turn that into me on their project, right? But some of them are not explaining what the screenshot actually means, right? Like they found these things. So pictures to me are just pictures, right? Imagine if I don't know what that is, right? If I am just a lawyer, I have to be able to take what you give me and explain it to the judge. So you have to tell me what you see, what you found, right? So as you go through the acquisition process, the more detailed your notes are going to be, the easier it is to summarize. So like the first week, you know how I give you all the questions, you answer the questions, and then together you put together the summary. So your summary is like a written report, right? But you have to expand on it a little bit more. So you can take pieces of your notes and then be able to put together your report, right? What these artifacts that you found, what are they? What do they mean? How is that related to, the case, etc. And then the type of tools that you use to find them and whether you validated the tools or not. And that's what they care about, right, in digital forensic. Okay. So for 4, it says, why should a digital forensic examiner pursue continuing education? I think we talked about that, to keep up with the field, with the tools, with the technology and the practices. And then the 4 elements, right? I should not put exam here, but examination. Copilot is kind of predicting what I'm typing. So. Right. So these 4 things we kind of need to think about when we go through our labs from here on out, and then our project down the line. Okay, for 6, I like to visit for you to visit this website. Right. Let me see if the hacking case is still there. Sometimes they change it. I haven't checked it today. So it's here. So this is my way of introducing to you usable data sets, right? So when we say data sets, basically they are images of cases, right? Could be real or fake cases. A lot of the time these are good for practices. You can go through a lot of different data sets. Some are new, some are old, some are very big. Android, iOS, and so on. If you're interested in some of the newer stuff with AI, there's deep fake, right? And you can, sometimes they're good at giving you like some of the free information, but sometimes it's just a data set. And then there's Droid Bench. So, you know, you wanted to investigate IoT. There's some stuff here. So we can come back to this. Rhino Hunt been around as long as I've been teaching. So this is kind of old. Which is kind of cool. I use it for the prior class project before. They're supposed to find a bunch of rhinos and pictures of different things. So it's fun to kind of go through it if you're interested. So these are pre-made data sets for digital forensic, and you can always find it on this website. Some of them sometimes go away, right? Sometimes they would add new ones. Bless you. So you would see newer data sets and then some of the popular data sets. So in our assignments, I have you go in and take a look at the hacking case, right? You would click on it, and then we want to kind of find out some information. And this is going to give us like some pre-information. So the scenario is that on 20 of September 2004, right? They found a notebook computer. That's a serial number, and that's what you're supposed to do, right? Once you find a system for the case, you have to document the make, the model of the system, and its serial number. It was found abandoned, right, along with the wireless PCM and CIA. So if you don't know what that is, right, if you're studying for A+, right, go look up what that is. But it's basically a wireless adapter that was used to connect the old notebook, right? In the early 2000s, wireless adapter that's USB capable is not abundant. So this is like an adapter that you would be able to connect to the laptop so it can connect wirelessly. Because back then, laptop was not wirelessly connected, even though it was a laptop, right? And then eventually it's completely mobile. And then they have a homemade external homemade 802.11b antenna. So that means that somebody had created like a rig for the antenna that is 802.11b is kind of old, right? We're currently on AC. Prior to AC, there was N, G, and then B was prior to that. So for the time, it was about right. In the early 2000s, that was 802.11b. Okay. And so now when you read this, you're like, okay, I'm interested in learning like who's the hacker, right? What did they attack? Then you would download, you see these images, they are in parts. Remember how when we create the images, it's limited to 2 gigabytes, right? So when you deal with a system that has very large data storage, what they have to do is they broke up the images into chunks. So you would start with the 001, you download that, you would put it through a forensic toolkit, right? We will work on something similar to this down the line. And then you scan it. You notice that is a DD based file. So it is part 1, part 2, part 3, part 4, part 5. Now you scan through all these 5 parts you would get, and each one you would make notes and then be able to have evidence of it, right? And then you would put together your summary report. Sometimes, and then you have to repeat it again to make sure that it's accurate, right? Using the same validated tool. So that's how you do it. Okay. So with that, we would answer the question, when did this incident occur? We already said it was on September 4th, 2004. Who's the suspect? We don't know yet, right? It doesn't say. It might be the laptop owner. Sorry, my anti-malware is. So it might be this Dell notebook laptop owner, we don't know. It was an abandoned notebook, so we don't have that answer yet, right? So when you go through a case like this, you have to state these questions. Who could be using the laptop, right? Was the laptop part of the attack, right? The incident that occurred, maybe on the network, right? Is there any correlation with the attack and the laptop being abandoned nearby? So when you read that information, see, they used to have more. Oh, this is the short description. Yeah, they don't have the long description. Let me see. Okay, I forgot to explain this. There's 6, 7, and 8 parts. But if you're using a different tool, right? Like FTK, you can use these multiple files, the E01, E02. So these are like the different type of files for different tool where you can use the 8 parts. So and then they also have like the log, right? And if you want to see the actual, they put this on a drive so you can visit this is really slow, just to let you know. Um, yeah, sometimes they don't format it, so it's basically go to their Google Doc or whatnot, but they do their best in maintaining it. And it changes throughout time. So as you can see, you can find your data sets information, right? So this is just a basic description. So we're unable to answer who owns the laptop, who's the suspect, right? How many images do you need for that investigation? Well, if you're using DD, you're going to need 8, right? How did I know that? If you go back to the website, this is when we click on the hacking case, right? You would see that if you click on the hacking case, there's part 1, part 2, part 3, part 4, part 5. I go to the next page, there's 8 parts. Then that's if you use DD. Now, if you use FTK or another software, you would need the E01, the E02. And then if you want to parse the log, this is a .log. Do you know how to access .log? Who knows how to access .log? Use the text editor, right? Now, some application is able to read .log, right? I know a lot of security system it reads .log well, but if you don't have the tool, we're gonna look at some logs later, but you can parse it through like Notepad, text edit in Apple systems, Nano in Linux. You can, open that up. Like if you use Linux command, right, you can open it up in a text editor or you can cat it using cat command. Cat stands for concatenation, where it actually read the file for you, right? And if it's not able to do that, you can parse it into a text editor. And because they are formatted as a text, right? All logs is it's basically a record of the system. So you can just parse it into a text editor. And we'll touch back on this when we talk about logs a little more. Okay, so what tool should you use to examine the image, right? I put down some answer here, Pro Discover. That's a free, well, I think the earlier version is free. DD, right? We saw DD in Linux, like Kali. You can also download or install DD on your Linux release. And then how can you validate the tool? In the last chapter, we talked about visiting this website. So you can say NIST, right? You can go reference the NIST Software Quality Group page or site, and then you can go through and take a look at the tools that they provide. I think we talked about that last time. Any question? So as you scan through, if you were to investigate, right, we want to know who this is, who owns that laptop, right? And what's on that laptop. So first we have to find out what's on that laptop. Then we can find out like, who's the user, um, or which account did they access on that laptop. Any question? Now you're not limited to just with these tools. You can use other tools, right? I will introduce you to some other tools. And like FTK, you can also use NKs. That's another one. Some are free, some are not. Okay, let me move maybe 5 down. Okay, for 7. It asks you, why should you use stereo media before the start and the end of the forensic process? So because if you don't have the capability to create a forensic image, right, or if you were forced to create a forensic image by copying the image, then you want to use clean media. That means that your external hard drive, your storage where your image is going to be, needs to not have anything else on it. Okay. So, and when you go through the process, like what I said, don't use your own personal smartphone to take pictures of the actual system, right? We want to use like a digital cameras for the case. So we want to have media that doesn't have other things like other cases, other data on it. So that way we can copy the image and it's not going to mix in with the existing data. Now, when you are copying, right, the image, or when you create the image to that media, you would need to examine. You use that disk to scan, so you don't want for it to scan everything else on it. Your software is really simple. It's going to scan everything at the destination, right, at the path that you point it to. So it will not know the difference between, old data or new image that you have. Okay. And then at the end of the investigation, evidence and case information must be removed and you need to wipe the disk clean. And you do this for every case, right? So your investigation information is then being backed up to somewhere else. Some company, they would have like a dedicated secure network drive that they will put the information there and it would be protected, like encryption would be used. But the storage, like the external hard drive or the drive on your laptop that you use to store the image for your case, that will get wiped. Okay, so when you say sterilize, that means that we want to zero out the disk where there's no remnants data. Because in some cases you will have malware, and when you do malware investigation, that can impact, right, other cases, you don't wipe it clean. And then you want to make sure that there's no pieces of data that would mix into future cases. So we want to wipe it. So how can you verify, right, if the media is sterilized? You would use a checksum tool, right? So currently, because we're using 64-bit system, we would use 64-bit checksum to validate the sterilization process. So if you understand checksum, right, all that is just looking at your binary values, okay? It's really simple in that if you have data, there has to be some kind of ones, right, stored in your storage. And if your storage is sterilized, everything is 0, right? So when you apply the checksum tool, it's going to verify if your storage is sterilized by looking at if there is data on your storage. Are there ones? Okay, and that's how it finds information. It will tell you whether it's sterilized or not. And we would screenshot that. We would say, okay, you know, I begin with this, right? Placing my image on a sterilized external hard drive, model number, WD, blah, 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 right? And then you will explain your process. So your report would entail the steps that you go through, the tools that you use, and what did you find out. It's like describing what you did to everybody else in the room. Okay. So what kind of tool can you use to sterilize the media? We already know how to check if it's sterilized, right? Paladin Toolbox. Paladin is a virtual machine. I explained this last time in Unit 2. There are other tools that you can use as well, but if you use it, I'm not sure if Cali Forensic comes with anything. I have to look at it. I'll let you know next time. But when you boot it up, you can also have a USB boot. When you boot it up, it's going to give you a virtual environment and you can go through and and it has an option to sterilize the media. X-Ways, it can also be used to validate if it's sterilized. So X-Ways is a software or a tool. Some toolbox would have multiple components so you can use it all in one. And then some you have to bring in additional tool. So security is about how vast is your toolbox and how knowledgeable you know your tools and what kind of outcome you want to get from your tools, right? Not just in forensic, but in ethical hacking, in analysis, risk assessment, and vulnerability assessment, same thing. Okay. But these are two examples of the type of tools that you can use for media sterilization and validation. Okay, so it talks about creating sterile media here. You can find this on page 3 of the notes, right? We talked about we don't want to mix that up with other data. You can also use MD5 or SHA or SHA hashing algorithm, but usually this is used for validating integrity of file. So once you carve out file, hashing algorithm is ideal. It's not recommended for this particular part of the process. Okay. Now we talked about Paladin. You can find them on the website. I mentioned before that there's a recommended donation to download, right? You can create a live USB because it is a Linux release. You can also download the tools and go through their instruction on how to use it. I wrote a lab for it, kind of challenging with the environment, the system that we use here, that we don't have administrator privilege to our system. So I scrapped the lab, but I can share that out if you're interested.
Where's the lab located?
I'm sorry?
You said you could share it. Is it?
Yeah, I can maybe put it on a page and then like, in one of the module. So I can, yeah. I wrote it and I tested it I think in 2023 with a group of students. I downloaded Paladin, I put it on USB and they successfully booted. But like the process and because you have to reconfigure that you can boot from USB and we don't have administrator on these. But if you have it at home, you can just throw it on a USB and then be able to do that. But yeah, I can share that out. Okay. All right. So the next part of the notes, it goes over write block, right? I think we mentioned this. We can buy a device that prevents additional data to be added to a disk or a storage. And because we're using sterile storage for our image for investigation, we want to add the write blocking because this is going to prevent additional changes to your evidence that cause contamination, right? So we want to make sure that we use the right block. Now, how can I find some right blocker? I can just search for it online.
$400.
Yeah, some are very, very expensive. You can be specific for digital forensics. Right? If you want to go shopping, it can give you. And you would see some would range in a few $100s, right? And then some would be very high in price, but they are definitely not under $100. Um, and then you want to go back to this and check if the right block that you're using is also tested, right? So before you buy it, you want to look at the model number and see if it's actually tested. And you want to buy the tested one, so that way it's a lot easier to
So
document.
How does that work? So you have your drive on your computer and you connect to the right block and then you plug things into
Yeah,
the
it
wall?
adapts. So it treats it like an adapter, so it's the middle component. Yeah, so you would plug, right? See how these are, it has like the power out. That's for the older drive. So if you have like the older hard drive, the IEE 40 pin with the missing pin, with the flat ribbon, you will plug that in. So that one, I'm not, but you have stuff like Tableau makes a lot of good right block. I recommend Tableau product. Like this one. Maybe you can go to the website. Oh, this is on eBay. 250, but this has a USB bridge. So likely that you would see modern drive today have bridge. If you pull SSD, um, SSD or like eSATA or anything like that, right? You can adapt it through a USB, and the adapter is about $25. So basically, it's a drive bay that you plug in. It has if you're using PCI Express for your SSD, right, for your storage, or if you're using like an older hard drive, like you have to use the other one, and then you will plug that into this via USB and then plug it into your computer. Or if you can also buy one that adapts directly to the drive. So it's important to look at the connection for the drive, right? The one that you select to see if it's able to adapt. Because even if they're affordable, you can't use it, then it's no good. Okay. So I just want you to put the link for number 11. Now that's a hardware write blocker. What if I don't want a hardware write blocker, right? I want to use a software write blocker. You can find a tool, right? That allows it to prevent any kind of changes to your image or the image of the system, and it would be controlled through the OS. Okay, so you have to install the software and then run it uh, while you're pulling the image and putting it into the drive, right? So it's gonna prevent anything from changing the integrity of the image. Now I put a link for Windows-based system registry change so you can prevent the USB devices to make changes, especially if you're using like hard drive or internal drive for your system. And it shows you how to enable the write protection for the USB devices, like the steps. This is just an article for you to show you how to do that. But the suggestion is another option is to use a bootable OS like Paladin Kali has a forensic version that's bootable to USB. And so you just need, I think, a 4 gig or higher USB. I would go with an 8 gig. So to give yourself a little bit of room, create that live boot USB, turn your bootable USB option on your system, plug that in, turn the system on, and it's gonna load the virtual environment through the USB. And then what you can do is you can go through, if you're using Paladin, it has the component where it allows you to set up the write block process for that. So knowing forensic, you kind of have to know a little bit of hardware. You kind of have to know a little bit about operating system, about file system, right? About, and sometimes a little bit of electronics, and that helps. Okay, so for number 12, it says in Windows system, how can you enable settings for write block? Simply change your registry to disable writes. And we're gonna spend like a whole unit on Windows registry because we can do a lot of things in Windows registry to find things, right? Anything that a user install, like let's say I download some kind of app and install on my computer, it adds that to my registry. Registry is basically a database or a list of your system configuration, hardware and software wise. So if we want to prevent, right, USB write block, that means that, store additional data to our USB storage, then we just need to go in and change the registry entry to make sure that we disable the rights to attach the USB. So that means that anyone plug in the USB on that system, beyond that point, they cannot pull data. They cannot write to the USB, right? It just disabled that port. You can also do that in BIOS, but when you modify that in BIOS, it actually modifies the hardware state of the component. So we can change the registry. And to run registry change, run regedit, right? You can search regedit on your system. So regedit is going to take you to registry editor. You have to have administrator privilege in this sense, right? See right here, we're going to spend a little bit more time in a later unit going over the H key. And each of these have a list of key values. Those are like just entry about your software and your hardware. So you can go in and modify. Okay, just a few more and we're done. Any question? No question. Okay, so I think we talked about this last time, right? When we make the forensic image, logical image, and forensic logical. So logical forensic image, just to clarify, that's files. We are going to do a lab where you're only going to look at that image as a file container, right? Like when you're going to carve out the file only. You don't care about the operating system, the application on it. No, we just want content. So let's say that if you're looking for images, you're looking for text messages, you're looking for, a file that they create, some kind of document, logical forensic image. So in the software, you would select this option, right? But if you want to capture the operating system, the app, and the files on that system, you do this image. Okay, forensic image would have everything about that system, right? And then the first option is similar to that, but this is just a copy. So it copies the state of the system along with everything else. I don't recommend the first option. You want to create an image and access the image this way. So earlier you saw the hacking case, it has like the E01. Yeah, that's an image. It's in two parts, right? So part one, E01, and E02 is part two. Sometimes they would, usually you would see DD image, right? E01, E0X, right? Or AFF. Those are the type of files that they use for forensic image or data sets. Okay, so it kind of expand a little bit more on like DD image, so you can create a forensic copy. I think in this semester, I'm going to add a lab where I'm going to make you do this, just kind of like the one that we did with USB, but I want you to make it so that way you can be more prepared for your project, because the USB one, I kind of made the last one we did, I kind of made it like a backup image, but we're going to make it maybe in multiple parts so that way you can see how that's done, right? Okay, so if you want a different version of DD, there's a DC3DD option. You can find the link there. But DD comes with Kali, or you can also install that on Ubuntu if you want to run Ubuntu or another release. Okay. And then your other option would be Ncase. I think this one, if you don't use the trial version, you have to pay. And Ncase also use E01, E02 type of image. A lot of software is compatible with those type of files, so you just got to make sure that you use the right tool with the right files. Okay, so the difference between your forensic image and your logical forensic image, the forensic image, it has the data file bit by bit copy of the source drive, whereas the logical forensic image, it has the specific data sets of the source drive. So usually this is a subset of the other one, right? So let's say that I only want the C drive of the system, then it becomes a logical forensic image. If I want the entire system, C, D, F, G, E, drives along with, you know, the apps, everything else, then I want to create a forensic image. Okay. So for a mobile phone, right, iOS, Android, depends on the case. If you want to look at the entirety of the mobile device itself, like how it runs, the type of apps, all the communication, then you do a forensic image. But if you're only interested in like what pictures they took, what kind of email they sent, what kind of text messages were stored or sent, then we would pull it as a logical forensic image, because it reduces the time that you have to go through and the software have to go through and examine everything. Because if you don't need all the apps and the app communication, right, then you don't need them. But you're gonna see that when we do one of the Android lab, right, we are gonna pull it. We're gonna look at all the apps like WhatsApp, you know, if they're on any kind of social media, what kind of stuff that they're on there. So you would see that it is a forensic image. Any questions? Okay, so the most two common type of files that you see, or the formats, usually they are DD, the .dd, right? Or it would end with E01 or E02, E0X, right? A number. And the DD, like you have learned in the last lab, it is limited to 2 GB or the size, because if you don't want it to chunk it too much, so 2000 megabytes is usually one. So when you have DD01, right, 2 gigs and then another 2 gigs. So if your system is 2 terabyte, guess how many parts you're gonna have, right? So the larger the data sets, the more stuff that you have to go through to skim and kind of filter out what you need to find. So I recommend looking through the notes specifically. It talks about CRC calculation for the sectors on how um, these type of tools are storing the image, and then your solid state drive. Okay. So huge difference, not just because of speed and performance, right? The way it writes data is dynamic, but here it talks about like how your leveling for the storage blocks is different for the solid state. The blocks for the storage drive is not overused, so they are overused sometimes if they are rewriting, because ultimately this is how what you see with flash drive, how they don't live too long. The technology is really made for simple use, and if it repeatedly being used over time, right, your block is being rewritten continuously, and there's a wear level. And then they're not made to go a very, very long time. The old technology, probably like USB 1, USB 2 might be, but they were really expensive for the USB when they first came out. Solid state is a similar, it uses flash-based technology. It writes based on addresses, very similar to your RAM. So everything is increments based on address blocks. And so you're still relying on the firmware so that way it can control the hardware level. So when you delete the file, it basically takes that address and put it back into the pool and say, oh, these addresses are now become available for the next files. And it just quickly pull the same addresses again when you are adding new files after you delete the old ones, right? Your smartphone does this when you're looking at internal storage or micro SD. Your micro SD just takes that address and make it available when you're deleting a picture or a file or an app. So what it does is just put that address back into the pool, and then it dynamically pull the addresses to be able to store additional file. So it talks about that here. In the OS, I know Windows has this and Linux has this. You can use something like a trim command. What that does is it takes the unallocated space, which is the space that it's given back to the system after the file is deleted, right? And it makes it become, actually, take the slack space and make it become unallocated. So slack space is kind of like, it's like the space where the deleted files go, and then the unallocated space is the space that's not being used by the system. So when you trim that, it takes the slack space and then dump it back into the unallocated space. Okay, another option that we can use, so some imaging tools. So I had students, when I taught this last year, they're like, at the end of the project, they're like, what can I use to create an image of your USB, right? And so we did some lab on it. But if you can go back to this notes, right, it's gonna tell you that there are options. So if you use FTK, right, you can also use Access Data. That's a free tool. There's a link for that. It allows you to create DD images, smart images, E01 images, or AFF. So this particular software allows you to create all formats. And you want the format that you can use with the scanning tool, right? So if I use FTK to create image, likely I would use FTK to examine the image, right? It makes sense. Like, I don't want to go get 5 tools just to one for each thing. If you create an image using one tool, you're going to use that tool to scan and look at the details, the artifacts inside that image. Okay, you can use a comparable tool to scan if it's compatible with the file formats. Now, comparable to FTK, the free version, you can use Pro Discover, bulk extractor. Those are some of the other. So we'll use some of these. And when you go through the process, it will start with a case number. Pro Discover does this. You have to give it a case number, some information, description of, and investigator information. So the software kind of walk you through all of those things, and make it easy. So at the end, it pulls all of this information and put it on your summary document which you can use for reporting. Easy. Okay. And I think that is all she wrote today. Oh, no, maybe more. I forgot. Just a few more. Okay. So for solid state drive, I know it's kind of long. We don't have to put it verbatim. What kind of issues are you going to run into when you're working with SSD? The benefit of SSD, we know that it is fast, right? Performance is good compared to HDD, hard disk drive. So we talked about the overuse of the blocks, and because they are not equally the same, this can lead to failure of your storage blocks. So it's ideal to get something that's fast and responsive, right? As a media where you could store your image. Just keep in mind that if you use it over time, you need to have a secondary drive for something that is, you would have multiple copies of that image on multiple drives, because halfway through, if your drive goes dead, right, you have to start all over again. You don't want to go and pull the image and then start all over again. Just have multiple drive with multiple of the same images copied, right? That way you have a backup. Now the firmware contains the instruction, right, on how we can interact from the software to the hardware. So we are relying on the firmware to be able to locate the data for SSD. And then when you use solid state drive, right, when you plug it in, the firmware sometimes moves the data around automatically because that's what it's instructed to do. So with that, you need to document that when you are going through the acquisition process in your case, right? You have to make a note of that in the case they question it. Like, you didn't move it, it's the firmware that did it, right? And you can pull the manufacturer information and be able to provide the backup explanation for that. And then I put, like we said earlier, when the user delete the file, the formats or the partition. So if I delete a section of the disk or I delete a file from the disk, it's going to do the garbage collection process where it trims, right? This changes the unallocated space. Remember what I said? Take the slack space and put it back into the unallocated. So it increased the address pool. It makes the unallocated space larger. So let's think of it like a house, right? You decided that you want to get rid of a room in the house. It gives you more space inside the house for nothing. No room, just and house, right? Just house. So when it trims, it takes away the deleted partition or the file. It gives you more space that's not allocated to anything else. It's still this space, but it's not to a room or it's not to a file, right? It's not to a partition. And it says that the unallocated space to be wiped or deleted data will no longer be as accessible. Now, yes and no for that. Not all disks will do the trim command right away, especially flash technology and micro SD. You can still find stuff on there because it put it into the slack. And then for the large drive, it's going to take a long time to image. Like if you're looking at terabytes or even gigabytes, like 500 gigabytes, that's going to take a while. Okay, because if we're breaking 500 gigs down to pieces of 2 gigabyte, you do the math, right? 500 divided by 2, you're going to have a lot of chunks. And then some of the things that you need to include on your final report or your documentation, and we will have the last unit, we're going to talk about forensic examination, testimony and all of those things, along with like what's on the report. So the last couple of units, we're gonna touch back on this, but from here on out, you need to, number one, give it a unique case number, right? Making sure that you document evidence number, because a lot of times you're gonna have multiple things, right? Or even if it's one system, you're gonna have evidence number. So the evidence number is just a unique number that's going to help you track which evidence, which device that you're working with for the case. You need to have a unique description that includes make, model, serial number, capacity, like size of your drive, like gigabytes, terabytes. And then notes pertaining to the case. You can say this belongs to a laptop for this location, etc. And this you can find also on the notes. And I think that's it. Any question? I'm gonna pull the other side out. I think it should be enough. So, before we take a break, right, we are gonna use the drive here to, in this case. All you need to do is copy the virtual machine to your desktop. Don't run the virtual machine on the drive itself, right? Just drag the 27A forensic image folder onto your desktop, and then you can open your virtual machine that way. And the lab gives you the instruction to do so. So when you're done, just make sure you return the drive so that way the other classes can use the drive, right? Not just my class, but some other people, they also use the drive. And then I will walk you through the lab. The lab is not very long. This is the second part of lab 1 that we didn't get, but I want you to have an understanding of there are multiple ways to analyze network traffic, because that's a lot. Many of you are in cybersecurity, and this is what you're going to be doing as incident responder. So I want you to take just like what we've done with Network Miner in lab 1, but we're going to use Wireshark in this lab, right? That's the part B of lab 1 that we didn't get to do. We're going to do that today. And we will have more labs that will be relevant to like specific data acquisition. So we would do that down the line, right? So just a little bit at a time. So today we're going to do more network analysis. All right, I'm going to stop and then we take attendance.